Okay, welcome to the next session. This is Robert Collins on Semver and Python for PBR. And Robert works on the continuous integration and continuous deployment team in the HP Cloud Services. And so he's been doing Python for quite some time already, and currently is walking the fine line between development and operations. And Robert has been involved in open source for many years, and has passion for high quality and well-tested software, as you might have seen already in the session earlier with Tommy. And he lives in Rangiora with his wife and young daughter. Over to you, Robert.
Thank you. So who here knows everything that was in the subject line, like PBR and Semver? I mean, I know you all know about Python. Hands up if you heard of PBR before. Okay, there is one hand up. No, two hands up in the room. Three. Wow, okay. And Semver, shortened Semantic Versioning. Right, much more. Okay, so this should be interesting. If at any point during this there's something that's not clear, please shout out. I will repeat it for the recording and try and answer on the spot so that things are clear as we go forward. I've reserved the right to defer anything to the end if it's going to be a long chat, but we've got a fair amount of slack for questions at the end. So PBR is, have I got my mouse in the right place? I don't. I do now, great. PBR is a Python build reasonableness, and it's a project we created in the OpenStack ecosystem as a result of some problems. But to understand these problems, we need to go back a bit in time. We need to go back and talk about Setuptools. And Anthony Baxter talked about Setuptools. Anthony Baxter talked about Setuptools back at LCA in Sydney, and he had a really, really good summary. He said, very clever code written by very clever people, and no one else understands it. And so we had that kind of problem happening in OpenStack for a bit. We have lots and lots and lots of fairly simple code, but it's lots of it. We've got dozens of different projects, and the environment it goes into is the standard deployment environment, which means it's complex. There's lots of different distros, lots of different optional backends, dependency may or may not be present, and you need to deal with all of that. Things have to just work. So we had this problem, and this problem was that we ended up with lots of copies of the build system code. So our Setuptools files all looked the same in all these projects, except for the string that said the project name, and the package name and the entry points were the scripts that we were going to run or the plugins we were going to load. Everything else was the same, and the way we kept it in sync was people manually copied it around. So that sucked. So we created a script to tell us what changes we need to make so that we didn't have to manually do it. And then we had people manually reviewing that we were changing the stuff, and it occurred to us that this is really a bad idea. What we should do is have a tool. So we refactored. I have just told you all about this. We refactored to have a single tool, which contained all of the logic, in which as we needed to change the logic. And an example of this would be, we needed a new module in Spinks that we wanted present everywhere. That's something we can do centrally. That's the sort of thing we were copying around. So PBR is that project. It's a Setuptools plugin, even though Setuptools doesn't really do plugins. It's a Setuptools plugin to change your project build to be data-driven and to have a whole bunch of sensible defaults, which we've found work for both regular apps, or command line tools, libraries that you're going to import into Python elsewhere, and full-blown API servers that are running over HTTP or whatever, and Django apps as well. Now, it's got a hard dependency on Git, and it does this because it does some useful things I'll talk about more later. And the Python distribution stuff has been evolving, and pip had some bugs, and we found all of them. That's not fair. Many people reported different bugs. We got hit by every single one of them, and some of them we were the first person to report, or the first group to report. And so we need a recent pip. Don't try and use an old one. If you're going to go down the path of using PBR, you've got to have quite a recent pip. I want to start by telling you how easy it is to get started with PBR, so you've got some reason to stay in the room and learn about the rest of it. This may be a mistake. You may go, I now know everything, and leave. We'll see what happens. This is an entire setup.py file for a standard OpenStack project. So this is, I think, about as simple as you can get and still have it actually claim to be Setuptools. We could, in fact, turn this into a one-line thing where we say import PBR, semicolon, PBR.doMagic. The problem is that Setuptools already has too much magic in it. It has this thing called Easy Setup. Who here hasn't heard of Easy Setup? I'm not going to scar you by telling you more. The rest of you are not allowed spoilers. When you start without pip and without a virtual env or anything set up in the Python world, it's a bit hard to get bootstrapped. This is being fixed. It is largely fixed in 3.5, but in 2.7 it's absolutely terrible. So going way back, I think back to 2.1 or something, there was this thing called Easy Setup which fixed all of that. And it's actually hidden under the hood in Setuptools. Even though Setuptools is modern and shiny and new, it has got this most evil piece of draconian software you've ever seen that runs random code off the internet for you under the hood. And that's why we can't make this a one-line thing that just uses PBR. It's got to come in through Setuptools. We do still have all of the metadata and all of the complexity. By the way, the slides are all going to be sent to your conference organizers, so you'll be able to copy and paste this, or you can find it on the web or whatever later. But we've got the full set of things, all your metadata. We can do, is the mouse pointer visible? There it goes. Project name, author, email, summary. This one's kind of nice. You write a regular long description and it sucks it up and puts it onto your PyPy page for you. The home page, your classifiers. But note that this is all declarative. There's absolutely no code. You don't have the opportunity to write arbitrary code here. That's actually a good thing. PBR takes patches, so we can improve PBR, make it able to express something it couldn't express before, and then everyone gets the benefit in a simple and it can't go wrong fashion. So with those two files, you can then take any Python Git project and pretty much it will just work. You'll be able to do setup, sdist, and you'll get it back out. It will have a version number. It will do the right thing. You do a tag to do releases. It changes it to a final version number, and so on and so forth. However, PBR's also got some integration in to know how to do better. No, it's opinionated defaults. It's not necessarily better. How to do our things, and we think that that actually is kind of useful to a lot of people. So one of the things it does is testing. So it's entry point integrated, and for all of the OpenStack projects, it exposes a test command. So if you do setup.py test, which is kind of an evolving standard command line entry to run the test suites for a Python program, this will actually run testr, the test repository tool that I'm, sadly for my sins, also a maintainer of, and report the results back out. And we don't actually offer a way to override that, so that might not suit everybody. On the other hand, it's unit test compatible. It can run any unit test suite, and we're using it for, I don't want to think about, it's probably several million tests a day nowadays, so it's battle tested. So this is the hard requirement, but it does some nice things. It picks up all of the version files in the tree. Now there is a Setuptools thing you can use that will grab all the version files as well, but we don't use that because we ran into race conditions. When you try and bring that in as part of doing your build, if you didn't have it previously installed, this goes back to that easy setup, I don't want to think about that nightmare. So we have a very simple implementation within PBR itself, so the PBR is a standalone dependency. You don't need to bring in a chain of things when you depend on PBR in your project. We scan the history and build a changelog file that contains the first line of your git commit for all of your commits, and we break that up by release. It's not particularly pretty, but it's very effective, and it's all that most people need. And we generate an authors file with the concordance of all of the author strings from all of the git commits ever in your tree, so that you don't need to manually maintain a list of contributors to your project. And if you're taking a patch from somebody else who doesn't use Git, you can override the author, and the author and committer can be separate, so you can still use this. You don't need to try and work around it. As I mentioned before, we generate this rich summary from the README. We don't currently do the changelog, but the changelog thing is planned. I'm thinking, actually, let me ask a question. Who here maintains a project, one or more projects in Python? Right, so about half the room. Would you want your changelog in the PyPy page for your project? I mean, I'm sure you've seen some projects that do it, and it's maybe not valuable, and some projects don't. Yes, no? Okay, everyone's hand is down, which means nobody wants it. We're going to revisit that feature. Well, there was one maybe in the audience. So, okay, Spinks has got this really nice thing where it can do man pages, and most people don't turn it on, and it can also do API documentation, but you have to write some stubs that depend on your package name for it to work. PBR will do both of those for you. Because it knows the package name as part of its metadata for installing stuff anyway, it can figure that out and just write it down to disk. It does, of course, assume that you're going to use Spinks. If you don't use Spinks, you don't put the entries for it in your setup.com config, and it doesn't get in the way. It's not a problem. But you should use Spinks. You really should. Oh, thank you. There's kind of an involved standard these days that you can do pip install -r and the requirements.txt as a sort of standard file name, and then a project can ship their dependencies in their source tree, so you can get going easily. We've taken that, we thought it was a good idea, we use it, but we've also added in a couple of other files like test-requirements, so you can separate out these are the requirements you need to run the thing, and these are the requirements you need to test it. And we've also got a variation of that where you can put a specific Python version. If you put a suffix of like 2.6 on the file name, then only if you're using Python 2.6 will those dependencies be brought in. And that's useful for dealing with situations like the discover module, which is needed on Python 2.6. It's not needed on 2.7 for testing because it's built in. One other thing we do with this, it's kind of interesting if you're in the position of dealing with multiple projects with one organization, is that you might want to make sure your requirement files are actually consistent with each other. So one thing we did in OpenStack is we have a CI job that just goes and looks at the requirements files for all the projects and compares them with a master list. And if we go and change the master list in a way that's not compatible with the existing requirements files, it says, hey, that's going to be an error, and you get a CI fail on your master list, and then you go and say, okay, well, I need to go and fix that in the individual projects, and you do that. And it also reports on what projects are out of date. So you've done a compatible change, but you've now got to go and update all your projects to make them the same if you want things to be consistent. And so this job actually submits merge proposals, pull requests, whatever your thing is, to fix up all of the other projects. So that's something that having a separate requirements file rather than having it sort of bundled into setup.py enables. I think that's one of the reasons it's become quite popular. So this is the bit I've been working on recently, and I'm really excited by because I hate having to think. I like thinking, I hate having to think. If I've got a job I want to get done right now, the last thing I want to do is to sit down and think really hard about whether I'm doing it right. So doing releases with semantic versioning is exactly that. You need to know, in the time period since the last release, have there been any API breaks? Have there been new features added? Have there been bug fixes? Or has it all been, we fixed a typo that can't possibly affect anybody in a bad way ever? So PBR now keeps track of that. On every single commit, you can document what sort of impact your change is going to have. And then when it comes time to do a release, it already knows the right version number. And in fact, when you do I'll show you a little bit later, not much later, a little bit later, that. But there's also this thing in PEP 440, which Nick was talking about earlier. It's huge, and there's so many different ways of modeling version numbers in a project. OpenStack was really clever about this. We chose 2 different ways for within the same project. Fortunately, that's very hard to confuse them. One way we do is we do this year.month thing, like 2012.1 is a version number for our API service, or 2014.10. The other thing we do is we do our clients, which are pure semantic versioning, like 0.0.1 or 1.2.3. Of course, we've got 2,000 contributors and not everyone actually understands that that's what we're doing. So the more we can automate this, the more consistent we're going to be. And I think that's important because folk who come to use a product like OpenStack don't look at it as 12 or 20 independent projects. They look at it as one big one. They expect some consistency. Whether that's reasonable or not is a separate discussion. The expectation is there, and when it's not fulfilled, people have trouble, and we don't want people to have trouble. So, semantic versioning, love it. It's really, really useful for communicating expectations from people who write some code to people who are going to use it. Whatever the API sort is, it doesn't matter. It's just a useful basic principle. Of course, the folk that wrote Semver.org wrote it for web APIs, which are completely different to things that you ship on machines in Debian or Red Hat packages. And the key difference is that your ability to talk about versions is kind of different because you now have a distributed problem. Rather than one website with a version you can depend on that API, you've got the problem where everyone may have a slightly different version of it with no actual common reference to trunk. I might be 5 commits ahead, you might be 10 commits ahead. So we've taken semantic versioning and we've added a couple of bits that we think are faithful to the original. I believe we proposed them as a pull request, but nothing's come of it. We wanted to be able to talk about pre-release builds. They still need versions. And we want to be able to talk about developer builds, that we want to track the Git hash so we can say is it the same build or not. And it needs some way of discriminating them from each other as much as we can. So we came up with this thing, OpenStack Semver, or I'll call it PBR Semver for the rest of the talk. And that's the pros from it. Format of pre-release and build labels to make them not confusing when coexisting with Linux distribution packaging. And we got inspiration from PEP 440 before PEP 440 turned into the union of every single way a version number has ever been expressed by any developer in the Python ecosystem ever. That made a lot of our stuff completely irrelevant. But we still took the inspiration and we've done all that thinking, so we just kept the answer we came up with before. I put this talk forward to both Kiwi PyCon and PyCon AU because the call for papers for both was open at basically the same time. I got accepted for both, which was a pleasant surprise. You've got a better talk this time because it's more practiced. But the first time around, Nick was in the room and we had a very good discussion in the middle of the talk about a bunch of this. So it's one of the ways it's better. It's been bug fixed. So, you know, what sort of thing, I think it's kind of interesting when you look at this to say, well, what stuff's gone wrong as we adopted semantic versioning. We added code into PBR to be able to predict the version numbers. The first thing is that before I started doing this work, we'd said, oh, we do Semver, and then we hadn't written any code to ensure that we did do Semver. And it turns out we really didn't do it very well. So if you were doing a dev build, like you've got a tag in your tree of 1.3.2, you've done a couple more commits and you do a build, what version number would you expect to get out? You wouldn't expect to get a version number out that PyPy and pip think is a full release. If it's not tagged, it shouldn't be a release, right? Actually, we were doing a tag, just adding in a serial number. So if you had a version of 1.3.2 and you'd done 5 commits, we gave you 1.3.2.5 as a version number. And this is actually really quite bad because people threw that through into build systems and so on, and nothing discriminated this from any other release except that it had 4 dotted decimal numbers rather than 3. Actually, it's hard for me to tell which things are here. Okay, the next thing we did is we found that people don't actually know the Semver rules. Just the other day we found Python glance client cleaned up some deprecated code. They removed some deprecated code, they put it in a release, they didn't bump the version number by a major number. This is backwards API break. This communication thing, we haven't actually educated everyone who's meant to be doing releases about the exact semantics they're meant to go on. Second thing is that's kind of at the course level, but at a more fine-grained level, is they don't actually know the exact syntax we came up with in this Semver for showing versions. So the 1.3.2.A2, it's kind of, as humans, we get that. But from a machine perspective, the 1.3.2.A2 is going to break in different ways the parsers for Semver that are out there versus the 1.3.2.0A2. So we wanted each dotted thing to begin with a numeral, or be, wildly different. We may find we're inconsistent, and it's we can't have nice things. So CD, who's familiar with the concept of continuous deployment? Okay, I'll take a quick segue and so the idea of continuous integration is, you do a bunch of development, and instead of finishing your arc of development, over like 3 or 6 months, and then trying to bring it back into alignment with trunk and turn it into one big code base again, you do that every day. So at the end of every day, you've made a little bit of progress, you merge it in, you figure it all out, and that way you don't have any big gaps that can arise. If there is API skew going on, you find out about immediately. For a bunch of folk, particularly in the corporate setting, it revolutionized a whole bunch of things about software development. But then we kind of got this whole web service thing where a whole bunch of stuff went from ship a product to, we're running a service. So that continuous integration was, we merged it in today, and then once a month we were doing a release to our server. And the same sort of skew opportunities existed there. You might have larger gaps against the schema than you thought, or maybe the performance needs were wildly different. So you actually want to get exposure to that code as you go as well. So continuous deployment, the idea is that you deploy the result of your labor immediately after verifying that it's okay. You don't wait an arbitrary period of time, you just do it. And so there are folk who do that with OpenStack. So every single day, something goes into OpenStack and it's starting down a pipeline that takes it to being deployed at Rackspace and HP and other organizations. And so these folk who are pulling trunk, they don't want version numbers to go backwards, ever. They want version numbers to keep rolling forwards. There's one kind of curly bit, no, I didn't give more details on this one. In the PBR Semver spec, we've got no way of comparing which has precedence, what's the order between an alpha version or any release candidate, pre-release thing, alpha, beta, gamma, release candidate, whatever, and a dev version. Developer versions, we can say, look, there are 5 or 10 or 20 commits past the last commit, so we can give a timeline there. And if you and me both are 10 commits on, we'll have a different hash, so we'll be able to say, well, we can't compare these. But if one's 9 and one's 10, we know that they are, one is more old or something. But with pre-releases, we can't compare them. And it's easy to say, hey, but you've got the Git history. The thing is, we've only got the Git history at the time we compile the version number. Once we put it into an egg or up on PyPy, we've only got the string. We've lost all of the other information that would let us do a really meaningful comparison. So we needed a special case stuff. So we can say, if you were doing continuous deployment, you can say, don't ever give me a release candidate version. Give me major versions, major, minor, whatever, full releases, or give me dev versions between them, but nothing else.
Robert, mouse cursor keeps covering the text.
My mouse cursor is being a naughty mouse. Thank you. So one of the things that has given us a little bit of grief is that everyone's been packaging the stuff coming out of OpenStack differently from a version number perspective. The folk who are packaging it locally for CD purposes, the folk who are in the distros, Ubuntu, Red Hat, and so on. One of the things that really kind of causes grief is the way we've been indicating pre-release versions. So who here has seen a Debian version number with a tilde in it? Right. Okay, did you know what it meant? One guy did. So a tilde means this sort's before no matter how the thing was, it sorts before. It's the lowest possible operator. RPM doesn't have this at all. Fine so far. We were doing pre-release versions with pip that had a tilde in them to say this is a pre-release version of this piece of software, and that had no meaning for RPM. RPM can't express alpha, beta, and so on. Once you bump the major version numbers, it's a major version number. The way people often deal with that is that they have local fields that they can use. But so that's still kind of an unsolved thing. We've stopped using the tilde. We now just semantically indicate it. But we can translate this into a binary version number deterministically. We've got a scheme for RPM and a different scheme for depackage, and people don't need to think about how they do their glue. They can just run the command and get it out. At the moment, the command is a Python API, but we're going to put a command line on it. You're about to hold that up, aren't you? Uh-oh. So all this PBR Semver stuff is new and shiny. It's in 0.11. 0.11 is not yet released. It was meant to be released this week. It hasn't been, I'm sorry. Was there more there? No. So we want to eventually move to a strict mode, so we'll give a period of time while we read every single version number that ever existed. Yeah, 1 minute, there we go. So the problem we had was that we had this epic fail. All of these version numbers were valid. And all of them are ones that I found bugs on past the initial code that we didn't parse properly. And the reason we have to read every single one is because people will be upgrading existing deployments. So we have to be able to take the new PBR code, read in what's in the existing install, and not crash. The history scanning stuff I talked about, this is kind of cool. If you've got like this version number and you do a commit that looks like this, note the big arrow. That Semver feature says this is a feature work. It's got to be a minor bump. It can't be a point release bump if you include this work in your trunk. Having committed it, the very next time you do PBR sdist, still I haven't done a release, but it knows that the next version has to be 0.11, not 0.10. And that's the full set of things you can use. So feature, API break, deprecation, bug fix, and you can mix and match them together. So it's just kind of, you get in the habit of I know what I'm doing in this commit, just document what it is, don't think about it, and at the time you come to do a release, you don't have to think later. Finish right now. So I'm going to go really quickly, less than a minute. You will be able to have a command that will do the tag for you because we know exactly what the command needs to be, and the Debian build things I mentioned before. Oh, this is also a useful thing. We can export the structured formats that are used by Python upstream. I talked about this before, and we have no time for questions because I was completely wrong about the timing of my talk.